Hello, today topic of my research is evolution of design patterns, exactly about observer. Observer it's a design pattern of behavioral type. Behavioral design patterns are conceptual solutions that help control the interactions between objects and classes in a program by defining their behavior and relationships to each other. They focus on how objects interact during program execution and how these interactions can be organized to make code more flexible, efficient, and easier to maintain. And how I said earlier, today I will talk about observer. It's a behavioral design pattern that creates a subscription mechanism that allows some objects to monitor and respond to events occurring in other objects. And let's start from the history of this pattern. Origin and early influences, 1970s and 1980s. The concept of the observer pattern can be traced back to Smalltalk, one of the earliest object-oriented programming languages developed at Xerox PARC in the 1970s. Smalltalk introduced the idea of objects that could subscribe to changes in other objects and receive notifications when those changes occurred. And Gang of Four or GOF design patterns 1990s. The observer pattern, as we recognize it today, was formalized and popularized and in the 1990s with the publication of the book Design Patterns, Elements of Reusable Object-Oriented Software. In the GOF book, the observer pattern is categorized under behavioral design patterns and is described as a way to define one-to-many dependency between objects so that one object changes state, all its depends are notified and updated automatically. Integration with modern software development. With the rise of modern software development practices such as component-based architectures, event-driven systems, and reactive programming, the observer pattern has continued to be relevant and widely used. Here is about technological advancements. Event-driven programming. The rise of event-driven programming paradigms influenced the development of the observer pattern. As systems became more event-centric, there was a need for standardized way to manage event notifications and reactions among objects. The second, industry trends and best practices. Code modularity best practices in software development focused on code modularity, reusability, and maintainability. Favored the use of design patterns like observe to decouple components and improve system flexibility. User experience, increasing user expectations for responsive and interactive applications push developers to adopt patterns like Observer to deliver real-time updates and seamless user experiences. And the last, it's component-based architectures. The shift towards component-based architectures such as Model Viewer Controller (MVC) and Model View Model (MVVM) created a demand for patterns like observer to manage communication and updates between loosely coupled components. And here about relevance, uh, reactive programming, fundamental in reactive paradigms, enables asynchronous event handling for responsiveness, uh, component-based architectures essential for MVC and MVVM, uh, facilitates modular development and easier maintenance. Event-driven system ensures seamless coordination in event-driven setups, enables components to respond to user actions and stimuli. Real-time applications, crucial for real-time systems like IoT and finance platforms, maintains data consistency and delivers instant updates. Frameworks and libraries integrated into modern frameworks, AG, Java, Observable, provides tools for reactive programming and event handling. And in the end of the research, I want to show the structure of this uh, design pattern. So that's all for the research. Thank you.